Welcome to video 3 of acid, base and salt. This one is on acid reactions. Okay, in previous videos we said what does an acid do, and an acid is a proton donor. So let's have a look at some acids donating protons. There's hydrochloric acid donating its proton, and you get the chloride ion. Nitric acid donating its proton, and there's the nitrate ion. And sulfuric acid, interestingly, donating 2 protons, and the sulfate ion. Okay, as I said in a previous video as well, these two, because they donate 1 proton, are known as monoprotic, and this one is known as diprotic. All right, it just means refers to the number of protons it's donating. Now, interestingly, when an acid, and obviously this is the acid side, and this is the proton side, what's this then? Well, this is the salt. Okay, so when an acid loses its proton, it becomes the salt. All right, and that's why we get salt every time an acid reacts. So this is the salt side. So when HCl reacts, you get chlorides. When nitric acid reacts, you get nitrates. And when sulfuric acid reacts, you get sulfates. And it's simply the acid minus the protons gives the salt. Okay, that leads us on to our acid reactions here. So the first acid reaction that we all learn in form 3, I guess, is acid plus metal gives a salt. Oops, a salt. Number 2, acid plus carbonate. Well, it gives a salt. And number 3, acid plus base gives a salt. All right. Oh, that's not how you spell salt, even vaguely, is that? There you go. Gives a salt. And acids always give salt. So that's one of the properties of an acid. Why do they give a salt? Well, they're an acid because they get rid of their proton. And if they get rid of their proton, what's left is the salt. So that's how it works. Now, obviously, they give other things as well. Acid plus metal is going to give a hydrogen as well. Acid plus carbonate is going to give carbon dioxide and water. And acid plus base is going to give salt and water only. All right, so these 3 are the things you must learn. These 3 acid equations. Interestingly, you've got to remember they give a salt, and you've got to remember the other products as well. All right, so let's have a look at two examples, say 2 or 3 examples. All right, let's use magnesium. It's always a good metal to use, and hydrochloric acid. Hydrochloric acid. By the way, these are word equations, and when you're writing a word equation, it should be the second word of the word equation should be on a different level. I hope you know what I mean by that. I'll try and explain it more. It's going to give, well, the salt is going to be magnesium, and since we're using hydrochloric acid, it's going to be chloride. All right, and the other product is hydrogen. Okay. Now, what I mean is this chloride is written underneath magnesium. It's not written at the side of magnesium. It's written underneath. All right, so let's change this into a symbol equation. It's going to be Mg plus 2HCl aqueous. By the way, all acids will be aqueous. Going to give us magnesium chloride. That's going to dissolve in the water of the acid, so it's going to be aqueous as well. And hydrogen is going to evolve as a gas. Okay, so that's acid plus metal. Let's do acid plus carbonate. Let's use copper carbonate plus sulfuric acid. It's going to give us copper sulfate plus carbon dioxide plus water, according to equation number 2 here. Okay, and let's do an acid plus base. Okay, the simplest of them is acid plus base. Let's do this in red. So the base is a metal, or let's not use magnesium, I've used it before. Let's use zinc oxide plus nitric acid. Okay, it's going to give us zinc nitrate plus water. All right, and you're going to have 2 of those, and I think that's it. Yeah, that's right. All right, so that's metal plus acid, carbonate plus acid, and base plus acid. Don't forget what a base is. A base is a metal hydroxide or a metal oxide. All right. That's what a base is. Now, what's reacting with what here? Well, if we have a look at the reactivity series, and we have to, I'm afraid, uh, potassium, sodium. Please send Charlie's, monkeys, and cute zebras in hard lead cages. All right, now I've got the reactivity series there. Let's move this up a tiny bit. Acids will only react with metals above hydrogen in the reactivity series. So acids will react with these metals, okay, but it won't react with these metals. I should clarify that. There's my timer, so that means we've gone over 6 minutes. So we're going to finish this video very quickly. So these will not react with dilute acids. There will be no reaction with these ones at the bottom, but with dilute acids, there will be a reaction at the top. Dilute acids, you will get a reaction with these. Now, that's because of displacement, okay, which you learned when you did metals. In other words, if the metal is above hydrogen in the reactivity series, it will displace the hydrogen. So it's a type of displacement reaction, isn't it? But if hydrogen is above the metal, for example, in lead and copper metal, there will be no displacement. Okay. So metals, the metals, not the oxides or the carbonates, the metals themselves will only react if they are above hydrogen in the reactivity series. Okay, that's this one done.